Hi friends, so most of my students are asking me to do problems from ray optics. So since board exams nearing, so they're asking me to solve problems from ray optics. So before going to start the ray optics, I'm going to split this into three parts. One is lens problem, another one is prism problem, the another one is the optical instrumentation problems. Okay, so today I'm just give overview, brief explanation about the lens, and then we'll do some numericals. So I'll just split into part 1, part 2 and part 3. So stay tuned for further updates. So first, what is meant by lens? So first we should know what is meant by the refractive index. So refractive index is nothing but whenever the ray of light moving from one medium to another medium, there will be a bending of light. Because whenever the ray of light moving from one medium to another medium, the velocity of the light will change. The velocity of light will change, that is the bending of your light. Similarly, whenever the ray of light moving from air medium to a glass with curved surface, is nothing but either it may be a concave lens or convex lens. So it's going to be change its path. So first we should try to understand what is meant by radius of curvature. We should try to understand what is meant by focal length and what is meant by center of curvature, and then what is my lens formula. So lens maker's formula I will explain in the next class, and then I will do more problems based on the lens maker's formula in the next class. So today we are going to solve only the thin lens formula and based on that problems. So first we should know what is meant by a lens. A lens is nothing but, if I have two spheres, so I have a sphere 1, I have a sphere 1, sphere 2. Okay, so we have two spheres. So the intersecting point is nothing but a lens. So this is nothing but a convex lens. So the distance from here to here should be R2. This is my interface 1. Actually, just imagine this. This is my lens. So this is my R1. So this is my curvature 1, this is my R1. So this is in the right hand side. So my R1 always will be positive. So from here, I'm going to take the distance from the center of this sphere is curvature 2. So this is my R2. So this is my radius of curvature of this first interface. This is the radius of curvature of the second interface. So my R1 is always positive because this is the right hand side of the lens according to a Cartesian sign convention. So what is meant by Cartesian sign convention? So if I have my lens or mirror, I can simply suppose take my lens here. Listen carefully. If you are taking the distance from the above the principal axis is going to be positive. Below the principal axis is going to be negative. So when you are measuring the distance from here to here, it's going to be negative. If you are measuring the distance from here to here, it's going to be positive, right? So the distance right side of the lens is going to be positive, the distance left side of the lens is going to be negative. Above the principal axis is positive, below the principal axis is going to be negative. So in this case, my R1 is the right side of this curvature, right? It's going to be R1 is going to be always a positive 1. So in this case, the R2 is the negative side of this interface. So my R2 is going to be negative, right? So these are the very, very important topics to do problems in the lens based problems. Okay, so first I try to explain. I need not to derive my thin lens formula because I already know that. My thin lens formula my 1 over f equals to 1 over b minus 1 over u. Okay, so this is my focal length, this is my image distance, this is the object distance, right? So 1 by v minus 1 by u equals to 1 by f. So my focal length is always positive for the convex. My focal length is going to be negative for concave. So these are the fundamental formulas required to solve the problem for the lens based problems, right? So these are the essential formulas required to do the problem today's class. Okay, so I will just erase this part. Then, so I have a convex lens of focal length f is equals to 30. F is equal to plus 10, and I have a a concave lens. Is a concave or it's going to be a planar concave? Sorry. It's going to be a plano concave lens. Okay. Then again I am going to place a convex lens here. So we have a focal length of, this is going to be minus 10, is going to be plus 30 centimeter, minus 10 centimeter. So this is my principal axis. So this is the question they given here. Find the position of the image formed of the object O by the lens combination given in the figure. So they are going to place the object here. We just want to find the final image formed because of this lens combination. If my lenses are in contact, we can easily find. So 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f2. So we are able to solve this problem. But here we have some finite distance between the two lenses. So here the distance between the object and this first lens is going to be 30 centimeter. So the distance from this point to this point is going to be, I think, yeah, it's given 5 centimeter. The distance from here to here is given as 10 centimeter. So here we have some finite distance between lenses. So if there is a lens, so we have to solve the problem separately. So first I am going to solve for this convex lens. So first I am going to start it for lens 1. Lens 1. So I am going to take my object distance is given, u equals to minus 30, f equals to plus 10, and then using this I am going to find my 1 by f is equal to 1 by v minus 1 by u. Therefore 1 by f, I simply put f1. So this is going to be f1, this is going to be f2, this is going to be f3, right? So f1, we already know my f1 is given 10. 10 minus equal to 1 by v plus, because minus into minus is going to be plus, is going to be 30. I think I am correct. So if I am simplifying this equation, so we are able to find my v1 is a v1 equals to 15 centimeter. So if you are simplifying this here, I am going to get my value of v1 equals to 15 centimeter. So the image produced by this first lens is formed at the 15 centimeter from this lens. So it's somewhere here. Okay, it's somewhere here. So this is going to be only 5 centimeter. So in the middle of that image, I am going to place my planar concave lens. So this is my planar concave lens we are placing here. So what's happening here? The image produced by the first lens is act as a object for the second lens, right? The image produced at is going to be this here. So I am going to write here, with respect to this lens, my object for this case, the image produced by this lens is act as a object for this lens. So with respect to this lens, my image formed somewhere here. So somewhere here. So 5 centimeters away from here. So I am going to solve for the lens 2. So my object distance u1 equals to 15. Listen carefully. Here somewhere 15. 5 centimeters away. It is going to be minus 5 equals to 10 centimeter. Sir, why you are taking u2? So object distance of the lens 2. Why it is plus 10? Because with respect to this lens is in the right hand side. This is very, very important. Right hand side, right? Okay, sir. Next, the focal length of the second lens is given. So f2 equals to what? This is going to be minus 10. So planar concave means, plane means the radius of curvature is going to be infinity. So this curvature only is given, is going to be what? Minus 10. It's going to be, oh sorry pa, it's going to be minus 10 centimeters. So 1 by f2 equals to 1 by v2 equals minus 1 by 10. I think so, I am correct. Yeah. So this is going to be f2, or we are going to substitute this value here, minus 10. If I simplify this, I am getting the value of is going to be v2 is going to be infinity. So it's going to be 1 over 0. My v2 is going to be infinity. So my v2 is going to be infinity means the image produced by this lens it's formed at infinity. Okay, which means which will produce the parallel beam for this. The image from this lens is going to be a parallel beam of light coming from here. So its image formed at infinity. So the parallel beam of light hitting in this, what's happening for the third lens? The image produced by the second lens is act as a object for the third lens. So I'm going to solve this for my lens 3, my U3. For this case, my U3, the object distance of the lens 3, U3 is going to be infinity. So my F3 equals to plus 30, and my 1 over F3 equals to 1 over V3 minus 1 over what's that? Yeah, it's going to be infinity. Then if I substitute this value, 1 by 30 equals to 1 by V3. Anyway, this sum is equal to 0. So therefore my V3 equals to 30 centimeter. So when the parallel beam of light coming from infinity hit the lens, the image formed at the focus of this lens from here is going to be 30 centimeter, the final position of the image formed here. So when the lenses are in contact, you can easily solve the problem. F1 1 by F1 plus 1 by F2 plus 1 by F3, you can solve this. But in this case, we have some finite distance, so we have to solve separately for this lens and this lens and this lens. So we have to solve the problem separately. So this is how we are going to solve the problem based on the thin lens formula. So if you have any doubt on this, just write in the comment. I will try to clear in the next class. Okay. So we will do one more problem in this session. So just copy this. Here the question is, when the image formed at point P, okay, the ray of light coming from some source and formed image at point P. When you are placing a convex lens here and concave lens here, we have two cases in the problem. So I just read the problem here. A beam of light converges to a point P. A lens is placed in the path of the convergent beam 12 centimeter from P. So from here also it's going to be 12 centimeter. So it's nothing at my U equals to 12 centimeter. So in this problem also is going to be U equals to 12 centimeter. At what point does the beam converges if the lens, first part, a convex lens of focal length 20 centimeter, now this focal length is given by 20 centimeter, and the concave lens of focal length of 16 centimeter is going to be minus 16 centimeter. So now we just want to find the image produced by this lens as well as this lens. So actually there is a convergent beam, so at point P. So in the middle of that beam we are going to place the convex lens here and concave lens here at 12 centimeter distance from the point P. So here in this case, the image produced at point P is act as a source for this lens as well as this lens. So first we are going to solve for this problem and then we are going to solve for this case. We just want to find this the image distance. But we already know my convex lens is a converging lens. So my image produced by this lens is somewhere here, right? It's a converging lens. So the distance from here to this is going to be, so my image will be produced at this point, it's going to be B. Okay, because my convex lens is a converging lens, my concave lens is a diverging lens. So the image is formed somewhere here. Listen carefully, it's diverging. Okay, my lens here, the distance from here to is going to be B. So we just want to find the image distance for the both the cases. So first I'm going to start with my U equals to plus 20 centimeter. So why we are taking U is plus 20? In general we are taking plus U is going to be negative, but in this case the image is in the right hand side of the lens. If this is in the right hand side of the lens, we are going to use only plus 20 centimeters. So after using my thin lens formula, 1 by F equals to 1 by V minus 1 by U. So 1 by F 20 equals to 1 by V is going to be again minus 1 by 20. So 1 by 20 plus 1 by 20 equals to 1 by V. So sorry, this is going to be 20 value. So my V will become, so actually I am doing wrong. Yeah, this is 12 centimeter, right? Sorry, I made a mistake here. This is going to be 12 centimeter. Sorry, pa. 12. So if we are taking LCM after solving 7.5 centimeters. 7.5 centimeters. So next, we are going to solve for this case. So in this case, my U is going to be plus 12 centimeters. So here, my image at point P is act as an object for this lens, right? So my image is also on the right hand side. My object is also in the right hand side. Both should be a positive. In this case also, U is also positive, V is also positive. So both image as well as object are on the right hand side of the given lens. So in this problem, I can simply solve my 1 by F equals to 1 by V minus 1 by U. Sir, why you are taking minus 16? Since it's a convex lens, we are going to take the minus. Sorry, concave lens for minus. Convex means it's going to be a positive one, focal length. So 1 by minus 16 equals to 1 by V minus of 1 by 12. So 1 by V equals to 1 by 12 minus 1 by 16. So after simplifying this, V is equals to 48 centimeter. So the distance from the midpoint of this lens is going to be 48 centimeter. So in this case, this V is going to be 7.5 centimeter. Since it's a converging lens, my distance is decreases. Since it's a diverging lens, my convex lenses, concave lens is always a diverging lens. So I'm getting image at the larger distance. So using my thin lens formula, this is how we are going to solve the problems. So based on my lens maker's formula, we will do more problems in the next class. So if you want to understand the lens maker's formula, we should know what's happening when the ray of light hitting on the spherical surface. So those things we will discuss in the next session. So I just stop at this point. If you like this video, share with your friends and subscribe our channel for the more content. We'll meet in the next video. Thanks for watching.